properties of cations in mixture analysis. Before going to analysis, let us see what is a grouping of cations in inorganic practical chemistry. Okay. So here, according to the systematic procedure, the cations are divided into following groups. The first group cations. In this group, Pb plus 2 and Ag plus is to be incorporated. Second group cations. This contains Cu2 plus and Pb plus 2, some sorts of Pb plus 2. Okay. Third group cations. So here this group contains Al3 plus, Fe3 plus, Fe2 plus. Fourth group cations. Zn2 plus, Zn2 plus, Ni2 plus, Mn2 plus, CO2 plus comes under this group. Is it clear? Fifth group cations. In this group, Ca plus 2, Ba plus 2, Sr plus 2 incorporated. Sixth group cations. This group contains NH4 plus, K plus, Mg2 plus. Okay. So after knowing the group division of cations in inorganic practical chemistry, one has to identify the cations, the group of cations present in the given salt. Is it clear? Let us see original solution. Before going to identification as well as conformation of cations, one has to prepare original solution of given salt. Okay. Here original solution can be prepared or is to be prepared by using the solvent in which the salt has solubility. Okay. So here usually in the laboratories, academic laboratories, most of the salts are soluble in water. So original solution can be made by using water as solvent. Okay. So now let us see what is original solution. It is very simple. It is a clear mixture or homogeneous mixture. A clear or homogeneous mixture of salt and solvent. Okay. So usually the water is used as solvent. Okay. Such solution is called as original solution. Okay. So during the preparation of original solution, one has to ensure the situation in the test tube like this. Okay. So here one has to take salt and solvent, and the analyst has to ensure the mixture is homogeneous. Such type of mixture is called as original solution. In the upcoming explanations, I will use OS as shortcut for original solution. One has to done the identification, group identification of cations or conformation of cations by using this original solution. I am repeating the making again. It is a clear mixture of salt and solvent, usually water. Okay. The situation in the test tube after making original solution will be like this, or should be like this. Okay. Let us see see identification of first group cations, that is Pb2 plus and Ag plus. Okay. Previously, I told that Ag plus is not to be given in the laboratories because the cost of the silver salts are too much. Okay. So, during the analysis of salt, one can expect only Pb2 plus in first group. Okay. Let us see the identification tests for first group cations. Here in this table, EXP abbreviated for experiment, OBS abbreviated for observation, INF abbreviates inference. Okay. Inference means simply speaking result. Okay. So now let us see the test for identification of first group cations. See here, test with dilute HCl. Test with dilute HCl. Okay, here the original solution of the given salt is to be added with dilute HCl. Okay, here I am taking OS for original solution. Okay, the expected observation if there is first group cations is a white precipitate is formed. Okay, let us see the first observation. A white precipitate is formed. I am writing the probable observations here. Okay, if a white precipitate is formed, then one can expect the first group cations in the salt. Okay, maybe first group cations. Okay, maybe first group cations. If there is no precipitate, then absence of first group cations. Absence of first group cations. Is it clear? Then the analyst has to go for identification of second group cations. Is it clear? The identification of second group cations, that is Cu2 plus Pb2 plus. See here, during the identification of second group cations, the following test is to be done by the analyst or student. Okay, see here. Original solution is added with dilute HCl followed by H2S gas. Followed by H2S gas. Okay. If precipitate is formed, there may be second group cations. Second group cations. Is it clear? If there is no precipitate, okay, second group cations are absent. Is it clear? Absence of second group cations. These are the observations during the identification of second group cations. Here, one has to take original solution into the test tube and then it is added with dilute HCl and then it is added by H2S gas. Okay. ఇక్కడ మనం ఏం చేస్తున్నామంటే ఎసిడిక్ మీడియంలో H2S గ్యాస్ని కలుపుతాం. ఓకే, ఎసిడిక్ మీడియంలో H2S గ్యాస్ని కలుపుతాం. ఇక్కడ ఫామ్ అయ్యే ప్రిసిపిటేట్ ఏమంటారంటే సల్ఫైడ్ ప్రిసిపిటేట్ అంటారు. ఓకే, సల్ఫైడ్ అంటే ఆ ప్రిసిపిటేట్ లో ఏముంటాయి, S-2 అయాన్స్ ఉంటాయి. ఐ మీన్ H2S లో S-2 అయాన్స్ ఉంటాయి. అక్కడ వచ్చే ప్రిసిపిటేట్ ఏమంటారు, సల్ఫైడ్ ప్రిసిపిటేట్. ఓకే, ఫర్ ఎగ్జాంపుల్ if copper is there, then one can get copper sulfide. Okay, if lead is there, one can get lead sulfide. Okay, sulfide precipitate usually second group లో కాపర్ ని మనం ఐడెంటిఫై చేస్తాము, కాపరే ఉంటుంది అక్కడ, కాబట్టి క్యూప్రిక్ సల్ఫైడ్ precipitate అనేది ఫామ్ అవుతుంది. Moreover, a student has to keep in mind the second group precipitates are sulfides. Okay, of third group cations. Usually the most common third group cations are Al3 plus, Fe2 plus, Fe3 plus. Okay, so let us see how one can recognize the presence of third group cations in the given salt. Okay, let us see. Here, original solution is added with NH4OH and NH4Cl. Here, NH4OH is aqueous solution, NH4Cl is solid. Okay, so to the original solution, after adding an aqueous solution of NH4OH, it has been saturated with NH4Cl. Okay, so test tube bottom lo కొంత NH4Cl అనేది మిగిలి ఉండే విధంగా మనం యాడ్ చేయాల్సి ఉంటుంది. Okay, so here let us see what type of observations one can expect if there is third group cations. Okay, if a gelatinous precipitate formed maybe Al3 plus. Okay, second observation, if brown red PPT formed, brown red, PPT means precipitate, maybe Fe3 plus, keep in mind. Okay, if green precipitate formed, maybe Fe2 plus. Okay, usually as usual, if there is no precipitate, absence of third group, absence of third group. Okay, so here like this we can write third group. See here, there is absence of third group cations, one has to proceed for identification of fourth group cations. Okay, the most common fourth group cations given in the laboratories are Zn2 plus, Mn2 plus, Ni2 plus. Okay, nickel 2 plus. So these are the most common fourth group cations. while analyzing the salt for identification of fourth group cations, the procedure has to follow like this. Okay. So at first, original solution is to be taken and then it is added with NH4OH, ammonium hydroxide. This is usually aqueous solution, and then it is saturated with NH4Cl. This is solid. Okay, and then this is added with the H2S gas. Keep in mind, during identification of second group cations, we have added HCl and then H2S. Okay, so there we have taken H2S in acidic medium. Okay, here while we are analyzing for fourth group cations, what we are doing, observe carefully, NH4OH, NH4Cl and then H2S is added. Here we are adding H2S in basic medium. Keep in mind, the fourth group cations precipitate as sulfides in basic medium. Okay. So here let us see the observations. If white precipitate formed, okay, so maybe zinc, maybe Zn2+, okay. If black precipitate formed, maybe Ni+2 or Ni2+. Okay. So if brown precipitate formed, maybe Mn2+. If you do this test perfectly, you need not to confirm the presence of zinc, nickel and manganese, because in crystal clear manner you can get precipitates. Okay, if white precipitate is there, zinc sulfide. If black precipitate is there, nickel sulfide. If brown precipitate is there, manganese sulfide. Okay, if there is no precipitate, absence of fourth group cations. Okay, absence of fourth group cations. If there is no fourth group cations in the given salt, one has to go for identification of fifth group cations, that is Ca2+, Ba2+, Sr2+. These are the most, Ca2+ and Ba2+ are most common cations given in the laboratories. Is it clear? Now let us see how the test has to done. See here, original solution and added with NH4OH and saturated with NH4Cl. Keep in mind NH4Cl is solid, and then added with NH4 twice CO3, ammonium carbonate. This is also aqueous solution. Okay. So, original solution is first added with NH4OH and then saturated with NH4Cl and then added with aqueous NH4 twice CO3. Keep in mind. Then here, if white precipitate is formed, okay, here only one observation you can expect, two observations. If precipitate is formed, if precipitate is not formed. Okay, so let us see, if white precipitate is formed, maybe Ca plus 2 or Ba2 plus. So we are not talking about SR2 plus right now, because usually it may not give in the laboratories up to UC. Okay. So maybe Ca2 plus or Ba2 plus. Let us see if no precipitate. Then what will be there? Absence of fifth group cations. Absence of fifth group. Okay. If there is no first group cations, second group cations, third group cations, fourth group cations, and fifth group cations in the given salt, the analyst has to test for sixth group cations, that is NH4 plus, Mg2 plus, K plus. The most common cations of sixth group given in the laboratory is NH4 plus and Mg2 plus. K plus is very rare cation in the laboratories. See here how we can test for these cations. Okay, they are very simple. See here, for NH4 plus. Okay. So if you suspect that there may be NH4 plus in the salt, then what you have to do, let us see. Original solution is added with NaOH and then heated. If you get ammonia smell, if ammonia smell is there, if ammonia smell is there, then the presence of NH4 plus is confirmed. Okay. So here Nessler's reagent to test another confirmation test for NH4 plus, but sometimes it will cheat us. Okay. Nessler test is based on the reagent and based on the contaminants present in the salt, that may be given even though there is no ammonia in the salt. Okay, ammonium in the salt. But this is perfect test. Okay. So if you get ammonia smell from the test tube after heating the original solution with NaOH, then you can confirm the presence of NH4 plus. Is it clear? For Mg2 plus, okay, then if you add NaOH to the original solution, if there is white precipitate, then you can confirm the presence of Mg2 plus. The name of the precipitate is magnesium hydroxide. Okay, name of that precipitate is magnesium hydroxide. Is it clear? For K plus, if ammonia is not there, then only you have to do for Mg2 plus. If Mg plus 2 also is not there, then you proceed for K plus. Keep in mind. So here what you have to do, you have to add sodium tetraphenyl borate. Sodium tetraphenyl borate. Sodium tetraphenyl borate is to be added to the original solution if you have or if you suspect there may be K plus in the salt. Okay. See here, a white precipitate formed. If white precipitate formed, what is that white precipitate? Potassium tetraphenyl borate. Sodium will replace Potassium. Okay, mean potassium will replace sodium. Okay. Then what is there? Potassium tetraphenyl borate instead of sodium tetraphenyl borate. Okay. The name of the precipitate is potassium tetraphenyl borate. What you are adding here? Sodium tetraphenyl borate to the original solution. Okay. Then you can confirm the presence of K plus ions. Okay. So this is about identification of first 5 groups of cations, and if there is no first 5 groups of cations in the salt, then we have to proceed for 6th group cations like this. Is it clear? So మనం ఇక్కడే కన్ఫర్మ్ చేసేయచ్చు వీటిని. After group identification of cations, one has to confirm the ion present in the salt. If one has identified first group cations in group analysis, then he has to confirm the presence of the particular cation in the given salt. Let us see, if first group cations identified, then the confirmatory test should be done for the presence of lead. Okay, let us see here. The presence of lead confirmed by adding potassium iodide to original solution. Okay, original solution plus Ki solution. If original solution, if lead is there, when the original solution is added with potassium iodide solution, yellow precipitate will be formed. Yellow precipitate will be formed. Okay. On heating, bright particles, keep in mind, bright particles of lead iodide, bright particles of lead iodide, PBI, appear. ఓకే, పొటాషియం ఐడైడ్ తో ఎల్లో ప్రిసిపిటేట్ వస్తుంది. ఆ ఎల్లో ప్రిసిపిటేట్ ని మనం హీట్ చేసి కూల్ చేస్తే, ఓకే, అప్పుడు మనకు లెడ్ ఐడైడ్ పార్టికల్స్ అనేటివి మెరుస్తూ కనిపిస్తాయి అన్నమాట. ఓకే, దెన్ Pb2 ప్లస్ confirmed. Okay, so this is confirmation test for lead cation. Okay, in group identification of cations, second group cations are identified, then one has to confirm the presence of second group cations in the given salt. Okay, the most common second group cation given in the laboratories is Cu+2. Okay, let us see the confirmatory test. Original solution is added with ammonium hydroxide, NH4OH solution, ammonium hydroxide solution. Okay, here if copper is there, Cu+2 is there in the given salt, at first blue precipitate is formed Okay, with excess ammonium hydroxide, turns to okay, deep blue. Keep in mind, deep blue. Okay, here on adding limited ammonium hydroxide, if copper is there, blue precipitate is formed. When it is added with excess of ammonium hydroxide, it turns to deep blue color precipitate. Okay. Then one can confirm the presence of Cu plus 2. One can confirm the presence of Cu plus 2. Okay. If third group cations identified in group identification, then we have to confirm the presence of the third group cation. Okay, there are three most common third group cations. You know that is Al3 plus, Fe3 plus, Fe2 plus. So in case of simple salt, only one ion among these three ions will present. Okay, so let us see what are the confirmation tests for those ions. Number one, for Al3 plus. If Al3 plus is there, then what will happen? Let us see. Original solution added with blue litmus solution. Blue litmus solution, keep in mind, and added with ammonium hydroxide solution. If original solution is added with a few drops of blue litmus solution followed by ammonium hydroxide solution, if there is floating blue precipitate formed, Al3 plus confirmed. This is also called as blue lake test. Blue lake test. Is it clear? Floating, keep in mind, floating blue precipitate formed. Okay, during this test. If then Al3 plus is confirmed. Okay. If Al3 plus is not formed, అంటే మనకు ఐడెంటిఫికేషన్ లోనే తెలిసిపోతుంది. Al3 plus ఉంటే వైట్ జెలటినస్ ప్రిసిపిటేట్ వస్తుంది గ్రూప్ ఐడెంటిఫికేషన్ లో. Fe3 plus ఉంటే రెడ్డిష్ బ్రౌన్ ప్రిసిపిటేట్ వస్తుంది. Fe2 plus ఉంటే గ్రీనిష్ ప్రిసిపిటేట్ వస్తుంది. గ్రూప్ ఐడెంటిఫికేషన్ లోనే మనకి హింట్ అనేది వచ్చేస్తుంది. దాన్ని బట్టి మనం ఇక్కడ టెస్టులు చేస్తాం. ఓకేనా? సో ఇప్పుడు నెక్స్ట్ ఫర్ Fe3 plus, when original solution is added with potassium ferrocyanide K4FeCN6. Okay, potassium ferrocyanide. Okay, then if there is deep blue color precipitate, deep blue precipitate, okay, is confirmed. Okay, let us see the test for Fe2 plus. The test for Fe2 plus. Okay, here the same reagent, that is potassium ferrocyanide, is to be added to the original solution. Okay, potassium ferrocyanide solution is to be added to the original solution. Then if there is pale blue or light blue, okay, pale blue precipitate formed, then we can confirm the presence of Fe2 plus. Confirm the presence of Fe2 plus. Okay. Like this, we have to do the confirmatory tests for third group cation. If fourth group cations identified in group identification, then one has to confirm the presence of either ion of these ions. Okay. So the fourth group cations are zinc, manganese, nickel. Okay. So when it is a simple salt, only one of these ions will be appear. Okay. Then we have to confirm that ion. Let us see. For zinc, confirmation of zinc can be done by adding potassium ferrocyanide. Potassium ferrocyanide solution to original solution. Okay, original solution. It will give white precipitate if there is zinc. White precipitate if there is zinc. Okay, then zinc, we can say that Zn plus 2 is confirmed. Zn plus 2 is confirmed. Okay, this is confirmatory test for zinc. Okay, let us go for manganese. For Mn2 plus ion, manganese ion it is. Okay, Mn2 plus ion. So here, original solution is added with NaOH solution. Okay, if there is manganese in the given salt, at first a white PPT formed. A white PPT, PPT means precipitate, okay, formed and rapidly turns to brown. And rapidly, అంటే oxidize అవుతుంది అన్నమాట ఇది. Rapidly turns to brown. Keep in mind, the final precipitate is brown. Okay, just it appear as white precipitate for a few seconds, and then it turns to brown. Okay, so then one can confirm Mn2 plus. Mn2 plus is confirmed. Okay, so this is about the confirmation of Mn2 plus. Okay, from Na2 plus of fourth group cation. Okay, fourth group cations. See here, during confirmation of Na2 plus, original solution is added with dimethyl glyoxide. Dimethyl glyoxide. Okay, followed by addition of NH4OH solution. Okay. See here, original solution is added with dimethyl glyoxide, and then it is added with NH4OH solution. Okay. Then, if there is Na2 plus, the precipitate is in bright rose color. Bright rose color precipitate formed. Bright rose color precipitate formed. Okay. Then one can confirm the presence of Na2 plus. Okay. So this is about the confirmatory test for fourth group cations. Okay. Let us see if fifth group cations identified in group analysis of cations, then one has to do confirmation tests for Ca2 plus and Ba2 plus. Okay. So now let us see how Ca2 plus, the presence of Ca2 plus can be confirmed. Okay. See here. Okay. For confirmation of Ca2 plus, the original solution is added with ammonium oxalate. I will write the formula here. Ammonium oxalate. Okay, ammonium oxalate. Okay, then the formation of white precipitate takes place. Okay, the formula of this precipitate is calcium oxalate. Calcium oxalate. Okay. See here what is happening. The ammonium is replaced by calcium. Okay. Calcium oxalate. Ca2 plus confirmed. Ca2 plus confirmed. Okay. So now let us see. We have to check in another step also before confirming the presence of Ca2 plus. Okay. This precipitate is completely soluble. Completely soluble. When this precipitate is completely soluble only, we can confirm the presence of Ca2 plus. If it is sparingly soluble, it is Ba2 plus. Okay. So if it is sparingly soluble, it is Ba2 plus. Let us see. For Ba plus 2 also the same test. Okay. But I will write the another confirmation test for Ba2 plus. Okay. We can confirm the presence of Ba2 plus by using ammonium oxalate. Okay. But to avoid the confusion, I am giving another test for confirmation of Ba2 plus. See here. This is also very simple test. Original solution is added with potassium chromate solution. Original solution for confirmation of Ba2 plus, original solution is added with potassium chromate. See the formula K2CrO4. Okay, potassium chromate solution is added. Yellow precipitate is formed if there is Ba2 plus. Yellow precipitate. Okay. Let us see the formula of the yellow precipitate is BaCrO4. Okay. Here barium replacing potassium. Here barium replacing potassium. If such type of precipitate is formed, then the Ba2 plus is confirmed. Ba2 plus is confirmed. Okay. If group 6 cations identified in group analysis, then one has to check for those ions. Okay. See here, for NH4 plus. So here what are 6 group cations? NH4 plus, Mg2 plus, K plus. Okay. For NH4 plus, original solution is added with NaOH solution and then heated. Okay. If ammonia smell evolved, ammonia smell identification of ammonia smell evolved. So then presence of NH4 plus confirmed. Okay. So brown color ఇప్పుడు OS with the restless reagent. This is test 1. Consider this as test 1. Consider this as test 2. If original solution is added with restless reagent, If original solution is added with Nessler's reagent, a brown precipitate will be formed. This is second one. A brown precipitate, but it is not to be considered as perfect test, being Nessler's reagent may be contaminated, okay, in so many cases. So the first test is to be considered as conformation test. So NH4 plus confirmed. Okay, if original solution is added with Nessler's reagent, then a brown PPT is formed, NH4 plus is confirmed. Okay. Number 2, for Mg2 plus, okay, so here this is also simple test. Original solution, OS means original solution, I am repeating again. Original solution is added with NH4OH. If a soluble white precipitate formed, a soluble white precipitate, PPT means precipitate, white PPT formed, then one can confirm the presence of Mg2 plus. Okay, name of that precipitate is MgOH twice, magnesium hydroxide. Here ammonia replaced by magnesium. Okay. Number 3, last cation of analysis. Okay, so this is also a 6th group cation, but it is very rare in laboratories. For K plus, this can be confirmed by adding perchloric acid. Okay. K plus can be confirmed by adding perchloric acid to original solution. Okay. A white precipitate formed. Okay. This name of this precipitate is potassium perchlorate. Okay. Then we can conclude that K plus confirmed. K plus confirmed. Okay. This is about the conformation of 6th group cations. సో ఇప్పుడు మనం బాగా గుర్తుంచుకోవాల్సింది ఏంటంటే, మనము అప్ టు క్లాస్ 12 అండ్ డిగ్రీ ఫస్ట్ ఇయర్, యూజీ ఫస్ట్ ఇయర్ వరకు సింపుల్ సాల్టే ఇస్తారు సిలబస్లో. సో ఒక సింపుల్ సాల్ట్లో ఒక యానియాన్ ఉంటుంది, ఒక క్యాటయాన్ ఉంటుంది. దానికోసమే మనం ఈ మొత్తం అనాలిసిస్ అంతా చేస్తూ వస్తాం. ఆఫ్టర్ గెటింగ్ రిజల్ట్ వీ హ్యావ్ టు రిపోర్ట్ దట్ ద ప్రజెన్స్ ఆఫ్ యానియాన్ ఈజ్ సో అండ్ సో, ద ప్రజెన్స్ ఆఫ్ క్యాటయాన్ ఈజ్ సో అండ్ సో. Then in higher studies they will give a mixture. Then there would be 2 cations, 2 anions up to UG level, and then in PGs more number of cations and more number of anions will be there in the mixture. Okay. సో ఇప్పటి వరకు మనం ఈ వీడియోలో మనం డిస్కస్ చేసినంతా కూడా సింపుల్ సాల్ట్ గురించే డిస్కస్ చేసాం. కాబట్టి మొత్తానికి ఎన్ని ఆనియాన్లు ఉన్నా మనకు ఒక ఆనియానే కనిపిస్తుంది, ఎన్ని క్యాటయాన్లు ఉన్నా ఒక క్యాటయానే కనిపిస్తుంది. ఓకే. Thank you for watching.